It's Jupiter. Did you even know that? It's Jupiter. Can you name the planets in our solar system? I'll do it for you. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. There's 8. There used to be 9, with Pluto as the 9th. But now, Pluto is not considered a planet anymore. It's now classified as a dwarf planet. So it's no longer in the mix. The ones that I listed are actually in order from closest to furthest from the sun. So, let me go over that again, and keep in mind that this is closest to furthest from the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The last one that would have been furthest from the sun would have been Pluto. But again, that's no longer considered a primary planet, but a dwarf planet. Have you ever heard the sing-songy rhyme in school about our planets? It's actually sung in the exact order that I just told you. And it goes something like this. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. But without the Pluto. If you can remember that sing-songy rhyme, you can remember the distance from closest to furthest from the sun. If you can't, well, there might be another little trick you could use. We'd have to think about it for a moment, though. But there is something interesting I can tell you outside of what I just told you about the order. Well, that order of the 8 are closest to furthest from the sun. There's actually another order that is from closest to furthest from the Earth. So, closest to furthest from the Earth would be the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and then Saturn. So did you catch that? The Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn. Saturn is the furthest planet away from Earth, and Neptune is the furthest planet away from the Sun. In that other order I told you about, we didn't qualify Uranus and Neptune because we were solely talking about the planets that align with the 7 days of the week. Now, let's talk about the smallest to the biggest planet, which you know now that the largest is Jupiter, since I told you that within the first minute. But what about the other ones? Let's do smallest to largest. The smallest to largest are Mercury is the smallest, unlike the others, might be a tad harder to remember. Although it is pretty easy to remember that Saturn is one of the largest, but not the largest, so that would be easy to remember that Saturn goes right next to Jupiter. But what about the others? Let's see if we can figure it out together. If we can remember that Mercury is the smallest and Mars is the second smallest, we can do a little trick with the M&M. Mercury, Mars, Mercury, Mars, Venus, Earth. Mercury, Mars, Venus would be easy to remember. Earth, Neptune, Uranus, Earth, Neptune, Uranus, E and U, E and U. I'm trying to figure out a little trick to help you remember that. Let's see. 3, 4, 5, 6, 7. I suppose we'll just have to see if you remember by the end when I ask you again. You'll have to form your own little trick. But let me tell you a little bit about our solar system in general. The solar system is the gravitationally bound system of the sun, and the objects that orbit it. It formed about 4.6 billion years ago when a dense region of a molecular cloud collapsed, forming the sun and a protoplanetary disk. The sun is a typical star that maintains a balanced equilibrium with the fusion of hydrogen into helium at its core, releasing this energy from its outer photosphere. Astronomers classify it as a G-type main sequence star. So, think about that. The solar system is a system of the sun and the objects that orbit it. It formed about 4.6 billion years ago. That's a long time, isn't it? 4.6. Can you remember that? 4.6. The largest objects that orbit the sun are the 8 planets. You know, the ones we just learned about. In order from the sun, there are 4 terrestrial planets: Mercury, Venus, Earth, and Mars. 2 gas giants, which are Jupiter and Saturn. And remember, those 2 gas giants are also the 2 largest planets. And 2 ice giants, Uranus and Neptune. So now that we know that 2 are gas giants and 2 are ice giants, we know the 4 that are the largest, remember? It'll help you remember that order from earlier. And remember, the terrestrial ones are Mercury, Venus, Earth, Mars, the first 4. The first 4 are the terrestrial. All terrestrial planets have solid surfaces. Inversely, all giant planets do not have a definite surface, as they are mainly composed of gases and liquids. Over 99.86% of the solar system's mass is in the sun, and nearly 90% of the remaining mass is in Jupiter and Saturn. Which makes sense, because Jupiter and Saturn are the largest, remember? There is a strong are commonly called moons. The solar system is constantly flooded by the sun's charged particles, the solar wind, forming the heliosphere, around 75 to 90 astronomical units from the sun. The solar wind is halted, resulting in the heliopause. This is the boundary of the solar system to interstellar space. The outermost region of the solar system is the theorized Oort cloud, the source for long-period comets, extending to a radius of 2,000 to 200,000 AU. The closest star to the solar system, Proxima Centauri, is 4.25 light-years away. Both stars belong to the Milky Way galaxy. Now let's talk about the formation and evolution. The past. The solar system formed at least 4.568 billion years ago from the gravitational collapse of a region within a large molecular cloud. This initial cloud was likely several light years across and probably birthed several stars. As is typical of molecular clouds, this one consisted mostly of hydrogen, with some helium and small amounts of heavier elements fused by previous generations of stars. As the pre-solar nebula collapsed, conservation of angular momentum caused it to rotate faster. The center, where most of the mass collected, became increasingly hotter than the surroundings. As the contracting nebula spun faster, it began to flatten into a protoplanetary disk with a diameter of roughly 200 AU and a hot, dense protostar at the center. The planets formed by accretion from this disk, in which dust and gas gravitationally attracted each other, coalescing to form even larger bodies. Hundreds of protoplanets may have existed in the early solar system, but they either merged or were destroyed or ejected, leaving the planets dwarf planets and left minor bodies. Due to their only metals and silicates could exist in solid form, in the form within the frost line. They would eventually form the rocky planets of Mercury, Venus, Earth, and Mars, because these refractory materials only comprised a small fraction of the solar nebula. The terrestrial planets could not grow very large. The giant planets, Jupiter, Saturn, Uranus, and Neptune, further out beyond the frost line, the point between the orbits of Mars and Jupiter, where material is cool enough for volatile icy compounds to remain solid. The ices that formed these planets were more plentiful than the metals present and future. The solar system remains in a relatively stable, slowly evolving state by following isolated, gravitationally bound orbits around the sun. Although the solar system has been fairly stable for billions of years, it is technically chaotic and may eventually be disrupted. There is a small chance that another star will pass through the solar system in the next few billion years, although this could destabilize the system and eventually lead millions of years later to explosion of planets, collisions of planets, or planets hitting the sun. It would most likely leave the solar system much as it is today. The sun's main sequence phase, from beginning to end, will last about 10 billion years for the sun compared to around 2 billion years for all other subsequent phases of the sun's pre-remnant life combined. The solar system will remain roughly as it is known today until the hydrogen in the core of the sun has been entirely converted to helium, which will occur roughly 5 billion years from now. This will mark the end of the sun's main sequence life. At that time, the core of the sun will contract with hydrogen fusion occurring along a shell surrounding the inert helium, and the energy output will be greater than at present. The outer layers of the sun will expand to roughly 260 times its current diameter, and the sun will become a red giant because of its increased surface area. The surface of the sun will be cooler, 2,600 K or 4,220 F at its coolest than it is on the main sequence. The expanding sun is expected to vaporize Mercury as well as Venus and render Earth and Mars uninhabitable, possibly destroying Earth as well. Eventually, it will be hot enough for helium fusion. The sun will burn helium for a fraction of the time it burned hydrogen. In the core, the sun is not massive enough to commence the fusion of heavier elements, and nuclear reactions in the core will dwindle. Its outer layers will be ejected into space, leaving behind a dense white dwarf, half the original mass of the sun, but only the size of Earth. The ejected outer layers may form a planetary nebula, returning some of the material that formed the sun, but now elements like carbon to the interstellar medium. So, if you've kept up so far, in billions of years, the sun will cease to exist as it is now, because even the sun itself, like us, has a lifespan. Luckily for us, it won't happen in our lifetime, but it will happen, and when it does, you heard them, Earth will cease to exist. It will be uninhabitable. Imagine living in that time. But we can't, because we won't. Let's talk about the general characteristics. Astronomers sometimes divide the solar system into separate regions. The inner solar system includes Mercury, Venus, Earth, Mars, objects closer to the sun, which are more affected by heat and light pressure, are composed of elements with high melting points. Objects farther from the sun are composed largely of materials with lower melting points. The boundary in the solar system beyond which those volatile substances cloud mollusks is known as the frost line, and it lies at roughly 5 times the Earth's distance from the sun. Let's talk about orbits. The planets and other large objects in orbit around the sun lie near the plane of Earth's orbit, known as the ecliptic. Smaller icy objects, such as comets, frequently orbit at significantly greater angles to this plane. Most of the planets in the solar system have secondary systems of their own, being orbited by natural satellites called moons. All of the largest natural satellites are synchronous rotation, with one face permanently turned toward their parents. The 4 giant planets have planetary rings, thin disks of tiny particles that orbit them in unison. And do you remember what the 4 giant planets are? So to remember which planets have planetary rings, you need to remember what the 4 biggest ones are. Those are the ones with rings, and the ones without rings are the ones that are not giants. So an easy way to remember this is that the 4 largest planets are Neptune, Uranus, Saturn, and Jupiter. So those 4 have rings around them. The ones that do not would be Mercury, Venus, Earth, Mars. Do you understand? That's a good way to remember. It would also be a good way to remember to say Mercury, Venus, Earth, Mars are the first 4 in the song. And then it goes Jupiter, Saturn, Uranus, Neptune. The last 4 are the ones with rings and are the biggest. As a result of the formation of the solar system, planets and most other objects orbit the sun in the same direction that the sun is rotating. Planets and most other objects orbit the sun in the same direction that the sun is rotating. That is counterclockwise as viewed from above Earth's North Pole. There are exceptions, such as Halley's Comet. Most of the larger moons orbit their planets in prograde direction, matching the direction of planetary rotation. Neptune's moon, Triton, is the largest to orbit in the opposite retrograde manner. Most larger objects rotate around their own axis in the prograde direction relative to their orbit, though the rotation of Venus is retrograde. To a observation, Kepler's laws of planetary motion describe the orbits of objects around the sun. These laws constellations can be accounted for using numerical models. But the planetary system can change chaotically over billions of years. The angular momentum of the solar system is a measure of the total amount of orbital and rotational momentum possessed by all its moving components. Although the Sun dominates the system by mass, it accounts for only about 2% of the angular momentum. The planets dominated by Jupiter account for most of the rest of the angular momentum due to the combination of their mass, orbit, and distance from the Sun. Let's go over what we've learned so far. Do you remember what the largest planet in our solar system is? We talked about it at the beginning. Yes, it's Jupiter. Do you remember the 8 planets in our solar system? And can you name them in order from closest to furthest from the Sun? I'll help you. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And remember, the 9th used to be Pluto, but it became considered a dwarf planet. Now, can you remember what I told you were the smallest to the largest planets? Let's do this together. Smallest to largest: Mercury, Mars, Venus, Earth, Neptune, Uranus, Saturn, Jupiter. That is the order we remembered. Let's do it again. Mercury, Mars, Venus, Earth, Neptune, Uranus, Saturn, Jupiter. And can you remember which 4 planets are the terrestrial planets? Yes. Mercury, Venus, Earth, and Mars are the terrestrial planets. And can you remember what the planets are that are the giants? The giant gas and the giant ice. Yes. It would be Jupiter, Saturn, Uranus, Neptune. And remember, Saturn and Jupiter are the gas giants, and Neptune and Uranus are the ice giants. Can you remember what I told you about which planets that are associated with the weekdays are closest to furthest from Earth? I'll help you remember. We have the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn. Can you remember that order? That's good. You're doing very good. I'm surprised by how much you've been able to retain in such a short span of time. You're very smart. I bet I could ask you a week from now and you would still remember. Do you remember how long ago and said that the solar system was formed. Yes, 4.6 billion years ago. And do you remember what is going to happen when the sun inevitably collapses, or I suppose deteriorates? Yes, Earth will become inhabitable. And do you remember when that's supposed to happen? Can you remember? Yes, in roughly 5 billion years from now. Which means it will not happen in our lifetime. I suppose that's fortunate, although it would have been interesting to see. But I guess it's one less thing to worry about, since we have enough to worry about, don't we? Way too much if you ask me. What's one fact you remember, outside of everything we just went over? What's one thing that stuck out to you? Let me hear it. I want to know which piece of information is an additional piece that you'll retain in your brain, for whatever reason, because I know there's one. There's probably multiple, but there's always one. So what is it? Share it with me. Really? That's interesting. And why is it that that is the piece of information that stuck out to you? Outside of what we've went over. I see. It's interesting to know how other people's brains work. Interesting to know what you pick up and put away versus what I pick up and put away. You see, the points that I found relevant or most worthy of stacking away in the brain are the ones that I've tested you on and have gone over repeatedly. And I do that multiple times to ensure that they stick in the recesses of your mind. Repetition